Nicknamed the Bone, the B-1B Lancer is a long-range, multi-mission, supersonic conventional bomber that has been in service with the United States Air Force since 1985. It is on track to continue flying with today's demanding operating tempo into 2040 and beyond, and Boeing is partnering with the Air Force to keep the B-1 mission ready. Originally designed for nuclear capabilities, the B-1 transitioned into a conventional combat role in the mid-1990s. In 1999, during Operation Allied Force, 6 B-1s flew 2% of attack missions, but dropped 20% of ordnance, and during Operation Enduring Freedom, B-1s flew 2% of attack while dropping over 40% of precision weapons. The B-1 has been in almost continuous use in combat operations in Afghanistan and Iraq since 2001. Carrying the largest conventional payload of guided and unguided weapons in the Air Force's inventory, the multi-mission B-1 is the backbone of America's long-range bomber force. It can rapidly deploy large numbers of precision and non-precision weapons against any enemy, anywhere in the world, at any time. The B-1B's mixed wing/body configuration, variable geometry wings, and afterburning turbofan engines combine to provide long-range, maneuverability, and high speed while increasing survivability. The forward wing arrangement is used for takeoff, landing, aerial refueling, and in some scenarios the use of high-altitude weapons. The stern wing sweep arrangement, the primary combat configuration, is typically used during high subsonic and supersonic flight, enhancing the B-1B's maneuverability in both low and high-altitude regimes. The B-1B's speed and superior handling characteristics allow it to integrate seamlessly in mixed-style packages. This capability, when combined with its large payload, excellent radar targeting system, long loitering time, and survivability, makes the B-1B a key element of any combined strike force. The B-1 is an extremely versatile multi-mission weapon system. The B-1B synthetic aperture radar is capable of tracking, targeting, and engaging moving vehicles, as well as self-targeting and terrain-following modes. In addition, the highly accurate inertial navigation system, assisted by the Global Positioning System, allows the crew to navigate without the aid of ground-based navigation aids and engage targets with a high degree of precision. Combat Track 2 radio provides secure long-range connectivity up to Link 16 integrated into the aircraft. In a time-sensitive targeting environment, air crews can use targeting data from the Joint Air Operations Center via Combat Track 2, then engage targets as they appear quickly and efficiently. The B-1B's self-protection electronic jamming equipment, radar warning receiver, ALQ-161, and throwable countermeasures, chaff and flare, and crane decoy system, ALE-50, complement its low radar cross-section to form an integrated, robust defense system, supporting the penetration of enemy airspace. The ALQ-161 electronic countermeasures system detects and identifies the full spectrum of enemy threat transmitters, then applies appropriate jamming techniques either automatically or via operator input. The current modification builds on this foundation. The continued radar and capability upgrades will provide a more reliable system and may be upgraded in the future to include ultra-high resolution capabilities and automatic target recognition. The addition of the Link 16 and FIDL combined with the associated cockpit upgrades will provide the integrated cockpit crew with a much more flexible integrated cockpit and will allow the B-1 to operate in the fast-paced integrated battlefield of the future. Several electronic systems that were obsolete and difficult to maintain were also replaced to improve aircraft reliability. The B-1A's engine was slightly modified to produce the GEF-101-102 for the B-1B, with an emphasis on durability and increased efficiency. The core of this engine has been reused in several other engine designs. including the GE F-110, which has been seen used on the F-14 Tomcat, the F-15K/SG variant, and the latest version of the General Dynamics F-16 Fighting Eagle. It is also the basis for the non-afterburning GE F-118 used in the B-2 Spirit and U-2S. The F-101 engine is the basis of the very popular CFM56 civil engine, which can be found in several versions of almost all small to medium-sized aircraft. The nose gear shutter has controls for the Auxiliary Power Unit, APU, which allows the APU to start quickly after a scramble command. A B-1B making a high-speed transonic pass, with the plane going through a shock wave during the Pensacola Beach Air Show in 2003. The B-1 has been upgraded since production, starting with the Conventional Mission Improvement Program, CMUP. This program adds the new MIL-STD-1760 Smart Weapon Interface to enable the use of conventional precision-guided weapons. CMUP starts with Block A, which is a standard B-1B with the ability to deliver non-precision gravity bombs. Block B carries an upgraded synthetic aperture radar and several upgrades to the defensive countermeasures system and was fielded in 1995. Block C provides enhanced capability for delivery of up to 30 cluster bomb units, CBU, per sortie with modifications made up to 50 racks bomb. The Sniper XR targeting pod is being integrated on the B-1 fleet. The pod is mounted on an external hardpoint in the aircraft's chin near the forward bomb bay. After accelerated testing, the Sniper pod was fielded in the summer of 2008. Future precision ammunition includes the GBU-39 small diameter bomb. In 2011, the Air Force was considering upgrading the B-1s with multiple ejector racks so they could carry 3 times the smaller dams than they can currently carry.